And so we'll get started with lecture section 2.1 in the LCMS learning track, the satellite imagery and custom Earth Engine libraries. So a review that freely available satellite imagery and cloud computation are what make LCMS possible. We have this wealth of satellite data collected from Landsat and Sentinel-2 satellites having orbited the Earth for, almost 40 years. And we have all this data that we need to crunch into meaningful information. Earth Engine means that we can access those data and that we can efficiently process them. So in a review on our satellite data record, we're using Landsat and Sentinel-2 satellites for this workflow. The main differences between these are that Landsat data has a 30-meter resolution, Sentinel-2 has bands at 10 and 20-meter resolution. Sentinel-2 also has some slightly different bands available for us, and importantly, it has more images available. So Sentinel-2 imagery are collected about every 5 days, as opposed to Landsat-2 every 7 to 14 days. So we've only added Sentinel-2 to the LCMS product for as recently as it's been available, so 2016 on. And this just highlights that we have much more satellite imagery available in over Peru and the U.S. Virgin Islands recently. It was really hard to obtain quality data there for much of the 80s and 90s. So we've shortened our study time on Puerto Rico to our training data only include those cloud-free data. So while Earth Engine provides a multitude of functionality, a lot of third-party libraries like GMAP, like GViz, have been developed to make using Earth Engine even easier. These libraries generally focus on further organizing Earth Engine's data catalog, or implementing best practices, or improving data visualization. Basically, bringing in functions that you might have had to write or construct on your own, but we've supplied those for you, like using another package like Terra in R or Pandas in Python. But unlike scikit-learn or Pandas or Terra, these libraries are maintained by people like us. So I think Ian is our chief maintainer of the GViz library, a party of one. And so they aren't quite as vetted as some of these bigger implementations are. So there are other custom libraries for working with Earth Engine and Python, GMAP among them, which we heard about a formal collaboration between GMAP and Google yesterday. There's GTools, and then GViz is a library that we have developed that we will be using for processing in this lab, and that LCMS uses for processing. So GViz was developed out of necessity by Redcastle in 2019 at the U.S. Forest Service Geospatial Technology and Application Center, or GTAC, which is where we chiefly work. So what it focuses on doing is helping users avoid common difficulties with Earth Engine. So it pulls in methods for compositing, for masking cloud shadows, for exporting, for resampling, and importantly, it also provides us this really slick visualization platform called GView, which we'll show many examples of throughout this lecture and subsequent lectures, which allows you to check out the results of your input as you go on. So it's like code editor, but running at each chunk in your Jupyter notebook. So it's a non-Python dependent map visualization and exploration tool. Our workflows run in Python, but we don't use notebooks in that end implementation, but we still do need to inspect those outputs. So you'll be running those outputs in notebooks, but that's not a part of our end workflow. So GViz allows us to intervene at any point to inspect what we're producing. GViz will also run in Colab and Workbench, as well as locally. And so it's going to be integral to these models. To these modules. And the modules will go into more depth on the specific functions, but right now we just want you to be aware of the fact that it exists and thinking about how we go about using and learning about a custom module. So that GitHub page also contains the GitHub page, for GViz in particular. Let's see, if I go back here. So you can access it through, we have a hyperlink on the slide, but if you search for the GViz library under the Google Earth Engine community GitHub page, you'll find the library. So that GitHub page also contains additional examples that you can run straight out of the box and documentation on all of those functions. So that's a great place to turn to if you're like, what is this function from the GViz library doing? Like using a help tool. I code in R primarily, so I'm really used to using that help tool to figure out like what the parameters are that go into a function with the same documentation within that package. And using and becoming familiar with those tools will serve you well using GViz and any other custom libraries. We've also included within that GitHub repo a folder called LCMS scripts. So these are some additional scripts that are taken specifically from the LCMS library that help simplify raster processing, that help simplify our accuracy assessment and validation steps, and also that help us manage COGS. So providing those snippets directly outside of the GViz module, they don't quite fit there, but they are essential to our workflow. So we want to give you all access to them. And again, you should be able to access the repo and use these scripts wherever makes sense for you. So the first lab section in this module is lab 2.1. And here you'll just be viewing functions and source code from the custom GViz library that was developed by Redcastle. So you'll notice that this example is generally focused on organizing data. So we're just getting those process Sentinel-2 scenes is the command here, and that's pretty typical of a lot of the functions in the GViz library. So if you'll navigate to section 2.1 and run the notebook to explore the GViz functions.